Dear learners, today we are going to discuss about joins. So displaying data from multiple tables. So that's the topic we are going to discuss. And the main objective of this learning is after completing this lesson, you should be able to do the following. So write select statements to access data from more than one table. Normally, in the previous classes, we have discussed about how to retrieve data from a single table. So today we are going to discuss about how to retrieve data from multiple tables and view data that generally does not meet a join condition by using outer join. And also we are going to discuss about join a table to itself using the self join. So different types of join operations we are going to discuss inner join, outer join, left outer join, right outer join, full outer join, cross join, then equi join, so natural join. So all types of joins we are going to discuss today. So it's an important topic because in most of the real-time applications, we need to retrieve data from more than one table. We'll see some example. So in this example, we have two tables. One is the employee table and the other one is the department table. Okay. So now, for example, if I wanted to retrieve data from both these tables. So from the employee table, I wanted to retrieve employee ID, department ID, and from the department table, I wanted to retrieve department name. So these three attributes I wanted to retrieve. So that means two tables are involved. Now we are going to see how to retrieve data from multiple tables. So for that, this Cartesian product, first we'll see what do you mean by this Cartesian product. When we discuss about this relational algebra operators, we have studied about different relational algebra operations like select, project, joins, Cartesian product, etc. So Cartesian product is the cross product actually. The Cartesian product is formed when the join condition is omitted and the join condition is invalid or all the rows in the first table are joined to all rows in the second table. So to avoid a Cartesian product, always include a valid join condition in a where class. Okay, so always remember as per the relational algebra operation, this cross product or the Cartesian product is represented using this operator, okay, cross operator. And normally we'll see an example. Assume that I have two tables. Okay, I have two tables. Table 1, in table 1 I have two variables. Okay, I have two variables a and b. Okay, so that is two attributes, and here I have two records a1 b1 as well as a2 b2. So these are the two tuples or rows in table 1, and again, I have another table that is T2. Okay, I have another table T2. So in this T2, again, I have two variables. Okay, so assume that I have two attributes C and D. So this is T2. This is T2. So here I have two rows C1, D1 as well as I have C2, D2. Okay, so these are the two attributes. And now, for example, how this Cartesian product works or the cross product, what will be the result of this Cartesian product is, what we'll do is we'll combine all the rows of the first table with all the rows of the second table. Okay. So when you take this particular row, okay, A1, B1, that will be combined with both the rows C1, D1 and C2, D2. For example, we'll see what will be the output of table 1 cross product or the Cartesian product table 2. Okay, so the result will be, you will be having attribute A, B, C and D. Okay, so in this the result will be, so in table 1 we have two rows and in table 2 we have two rows, right? Here we have two rows and here we have two rows. The result will be 2 into 2. So totally we'll be having 4 rows. So the first row will be A1, B1 and then the first row of the second table. Okay. So that is C1, D1. Similarly, take this first row of the first table, that is again A1, B1, and the second row of the second table, that is C2, D2. And now you consider this next row, okay, consider this next row of the table 1. So A2, B2, C1, D1, and then again A2, B2, C2, D2. That is the second row from the second table. So combination of all rows from table 1 and table 2. So that is Cartesian product. So here there is no join condition. Join condition is omitted. And actually, this Cartesian product is a very costlier operation. Okay, when we consider two rows, it will be simple, but in the real time application, you may have hundreds of rows. So, if you apply this Cartesian product, it is a very costlier operation. Okay, so normally you have to avoid this Cartesian product. And we apply join condition. So, what is this join is represented or denoted using this particular operator? Okay, so this is the relational algebra notation for join. And what is join is? Join is equal to cross product plus selection. So selection is nothing but the condition or the predicate. Okay, so it is selection, that is Cartesian product. Join is equal to Cartesian product plus select condition. That we call it as joins. Okay, now we'll see. This is the example they have given. So they have 20 rows in this example. Okay, here you have employee table with 20 rows. And similarly, we have assumed that we have department table with 8 rows. So what will be the result? You will be having 160 rows. That means 20 into 8. So totally 160 rows will be the output. Okay. For example, as per the previous example, what are the details I need? I need the employee ID from the employee table, department ID from the employee table, and this location ID from the department table. Okay. So what will happen is all combinations will be taken. All combinations will be taken and totally you will be having. So when you apply Cartesian product, all possible combinations from both the tables will be taken. So in this example, you will be having 160 rows. Now we'll see what are the different types of joins. Joins is Cartesian product plus selection. And as per this Oracle proprietary joins, that is 8i and the previous versions, in that we have different types of joins. One is equi-join, then non-equi-join, outer join, and self-join. But now we have so many latest versions are there in SQL 1999 as well as after that. Okay, so as per this SQL 1999 complaint join, there are different types of joins: cross join, natural join, and also using class, full or two-sided outer join. Because outer join we have three types. Okay, outer join we have three types. One is left outer join, okay, right outer join, as well as full outer join. So there are different types of outer join. So in the later part we'll discuss this types of outer join in detail. As well as we have arbitrary join condition for outer joins. And joining tables using Oracle syntax. Now we'll see what is the syntax for joining tables using Oracle. So use a join to query data from more than one table. For example, I wanted to retrieve column from table 1 as well as some column from table 2. So in the from class you have to mention those two tables, table 1 and table 2, where you have to give a join condition, so table 1 dot column 1 is equal to table 2 dot column 2. So what's the join condition? That has to be mentioned. Where the join condition is mentioned, write the join condition in the where class. Prefix the column name with the table name when the same column name appears in more than one table. For example, you consider the previous example. In this example, we have two tables, employee table as well as department table. So in employee table also you have an attribute called department ID, and department table also you have an attribute called the department ID, right? So with the same name we have attributes in both the tables. So to differentiate, what you have to do is you have to prefix the attribute name with the table name. So you have to mention like employees dot department ID, and here you have to mention like departments dot department ID. Got it? We'll see what is a equijoin. In the join condition, I said in the where clause we have to give the join condition. So in the join condition, okay, the condition, okay, the join condition, if it has an equality operator, okay, equal operator. So in that case, that join we call it as equijoin. Whenever if it is matching, okay, that will be retrieved. So normally when you see here in this employee table, we have department ID. Similarly, in the department table, we have department ID. So here this department ID is the foreign key and this department ID is the primary key. This department ID is referring to this department ID. Okay, so in the join condition, we'll use this department ID as the join attribute. And now we'll see how to retrieve records with equijoin. In this example, what you are selecting in the select class, we are giving employee ID from employee table, employee's last name from employee table, plus we are choosing this department ID from employee table, and also we are choosing department ID from department table and location ID from department table. So in this case, we have to mention the table names in the from class. So we are mentioning two tables, no? So first table employee table and the second table is the department table, where the joint condition is department ID, where employee dot department ID is equal to department dot department ID. So we are combining, okay, so we are comparing this. Okay, so we are comparing the department ID in the employee table and the department ID in the department table. So that is we are using this as the join condition. Okay. So in this case, when you see the example, here if it is 10 and here also if it is 10, only that rows will be selected. Here also it is 20, here also it is 20. Okay, so only those rows will be selected. Okay. And for example, in addition to the join condition, if you wanted to add more conditions, in that case, you can use AND operator. You can use AND operator and add those condition as well. So that is also possible. And now what you can do is qualifying the ambiguous column names. Use table prefixes to qualify the column names that are in multiple tables. That's what I have told you. Department ID is the attribute name department ID is present in employee table as well as in the department table. Okay, so it is ambiguous, right? It is confusing. So to avoid that confusion, you have to prefix the table name before the department ID. So it improves the performance by using table prefixes. Distinguish columns that have identical names but reside in different tables by using column aliases. And simplify queries by using table aliases. See, for example, each time when you mention the attribute name, each time when you prefix the table name, you have to type employee or department, right? Instead, what we can do is you can use an alias name. So, how to use that? Here, I'm giving employee E as well as department D. Okay, so what you can do is instead of this employee, you can use this E. Similarly, instead of this department, you can use D. Okay, so some alias name we are using. That's why here instead of mentioning employees, I am mentioning e dot employee ID. Okay, wherever I have to use employees, okay, I am using e. Similarly, wherever I have to use departments, I am using d. Got it? So this is simple to write the queries, right? So that's why we are using table aliases. And joining more than two tables. In the previous example, we have seen how to join two tables. Assume that if I wanted to join more than two tables, in this example, we are going to join three tables. So one is the employee table, another one is department table, and the third one is location table. So we have three tables. Okay. So here in this two tables, employee table as well as department table, department ID is the common attribute. So we are going to join these two tables, employees and departments, using this common attribute department ID. Similarly, when you compare this department table and location table, this location ID is common. Okay, this location ID is common. So that is the joint condition between the department table and location table. So one thing you should remember, for example, if you wanted to join n tables, kindly note it down. If you wanted to join n tables, how many conditions you need? You need a minimum of n minus 1 join condition. Okay, in this example, okay, we wanted to join three tables. So how many join condition is needed? Minimum of two join condition is needed, because our n is equal to 3. So join condition we need is at least two join condition is required. And another one is non-equijoin. That is, we are going to compare a different value. Okay, we are going to compare a different value. See here, here actually we have two tables, employee table and job grades. This is another table. What you're going to do is, we are going to compare the salary table, okay, with the lower salary and higher salary. What we wanted to do is, salary in the employee table must be between lower salary and higher salary. What we are going to choose? We are going to choose the salary in the employee table, okay, which lies between the lower salary and the higher salary. So this salary is compared, okay, the salary is compared with this lower salary and higher salary. So this type of join, okay, so here we are going to compare between lowest and highest. So this is not a equijoin, this is a non-equijoin. So salary in the employee table must be between lower salary and higher salary in the job grade table. So how to write the query for that? What we wanted to retrieve? We wanted to retrieve last name, salary, grade level from these two tables, employee as well as grade table. So employee table, we have given an alias name E, and for job grades, we have a user alias name J, where we are checking the condition, where E dot salary between lower salary and higher salary of the job grades. Okay, so this will be retrieved. And then you should understand what is an outer join. Normally, when you apply equijoin or inner join, what happens is, in both the tables, whichever rows are matching, only those rows will be retrieved. But sometimes, for some applications, we may wanted to retrieve the rows that are not matched. Okay, in that case, if you wanted to retrieve the values that are not matched between these two tables, then in that case, you have to go for this outer join. Okay, in this example, there are no employees in department 190. So we have two tables, department table and employee table. When you see the employee table, there is no department called 190. When you compare the department ID, there is no department ID called 190. So this 190 is not matched with employee table. Even then, that will be retrieved. If you wanted to retrieve that, in that case, you have to use the outer join. We'll see the syntax. You can use an outer join to also see the rows that do not meet the join condition. That means if you wanted to have the unmatched rows also, in that case, you have to go for outer join. And the outer join operator is the plus sign normally in your okay, in your Oracle syntax actually. So here you will use this plus sign. What's the syntax? Select table 1 dot column comma table 2 dot column from table 1 comma table 2, where table 1 dot column, here you have to use plus. Okay, so to mention it is an outer join, to mention it is an outer join. So what do you mean by that? That means this table 1 dot column, even though it is not matched, all the rows will be retrieved. Okay, similarly, if you wanted to match all the columns in the right side table, then you have to mention the plus symbol here. Okay, so in that case, in table 2, all the rows will be selected. See here, select last name, comma, E dot department ID, then D dot department name from employee table E and department table D, where E dot department ID, so here we have used plus, right? So all the rows, or that is all the values in the department table will be retrieved. Okay, all the rows in the department table will be retrieved, even though that is not matched, even though that is not matched with the next table. Okay, so that's why I told you no. So this 190 department ID 190 is not matched with the department ID in the department table. Even then that value is getting selected. Okay, that value is getting retrieved. So this is outer join. So what is outer join is, even though the rows are not matched, it will retrieve those values as well. And then we'll see self join. Sometimes we may wanted to join attributes in the same table itself. Okay, we may wanted to join attributes in the same table itself. Then we call that join as self join. Here we have an employee table. Okay, so in that employee table we have employee ID, last name and manager ID. Okay, so this manager ID, employee ID is there. Who is a manager? Manager is also an employee. Okay, manager is also an employee. So this manager, okay, 100 is a manager. Okay, so for him there is no manager ID. But for employee number 101, who is the manager? 100 is the manager. And for 102, who is the manager? 100 is the manager. And for 103, who is the manager? 102 is the manager. Okay, at the same time, this manager is also an employee. That's why this manager ID, actually it is referring this manager ID. Okay, so in this case we call that as self-referential integrity constraint. Self-referential integrity constraint. So this is a foreign key. Okay, so this manager ID is a foreign key and this employee ID is a primary key. And now we wanted to join these two operators. Okay, we wanted to join these two tables. So manager ID in the worker table is equal to the employee ID in the manager table. Now we wanted to join these two tables. Actually, the table is same. Okay, and we wanted to combine this manager ID and the employee ID. Now you see, select what are the things we are going to retrieve. Last name as well as, okay, we wanted to retrieve this last name. Okay, and this is a string that we have given, and manager dot last name that we wanted to retrieve from employee. Here actually this is an alias name. Employees worker, employees manager, same table we are using, same table you are using. That means this is E1, you can have this as E2. Okay, so to understand, here we have mentioned that, okay, worker and manager, where this worker dot manager ID is equal to manager dot employee ID. Okay, so this manager ID, this manager ID is equivalent to the employee ID. This manager ID is equivalent to this employee ID. So this two we are joining. Okay, this two we are joining, but both those both the attributes are from the same table. How we are joining is using alias name. So now we are going to see joining tables using SQL, that is 1999 syntax. This is another way of performing join operations. So use a join to query data from more than one table, that we know. Now we'll see another way of representing the join operation. This is another syntax. Kindly note it down. Normally we use this syntax only, we don't use that plus symbol. Okay, practically speaking, we use this syntax only, so kindly note it down. So select table 1 column comma table 2 column 2 or whatever it is from table 1. Okay, then you have to mention what type of join you wanted to perform. That is, whether you wanted to perform a cross join, or you wanted to perform a natural join, or you wanted to perform a join using, okay, using this class, using class, okay, or using the normal join on class. So there are different ways in which you can perform the join operation. Either it might be a cross join or natural join, or you can join using this using class. We'll see example. Also, you can mention whether it is left outer join or right outer join. I told you that outer join has three types: left outer join, right outer join, full outer join. So whenever there is this R symbol, that means it is optional. Okay, either left or right or full, that you can specify. Okay, now we will see an example, then you will understand. What is this cross join? This cross join is the cross product or the Cartesian product. Okay, so I have told you, no, I have given you an example, Cartesian product. So it consider all possible combinations. So the cross join class, it produces the cross product of two tables. So this is same as the Cartesian product between two tables. So what's the syntax? Select last name comma department name from employees. Here, if you wanted to apply cross join, then you have to mention cross join department. So in the previous example, in the from class itself, we have mentioned both the table names. So here what we are going to do, we are going, that is from employee table cross join with department table. Okay, employee table cross join with department table. So this is the syntax for applying cross join. In the previous example, what we have seen, so how to do that in the previous example? In the previous example, okay, as per the previous syntax, for example, we have to give select, okay, last name, comma, department name, okay, from both the tables we will mention in the from class. Okay, you have to use in the from class, you will mention the employee table, okay, employees table, comma, departments table. Okay, comma, departments table. That's all. You don't give any condition. If you give condition, that is join. So here it is Cartesian product. So when you simply give the table names in the from class, it will take all possible combinations. Okay. So this syntax is similar to this only. This cross join syntax is similar to the previous syntax what I have given. And the next one is creating natural join. The natural join class is based on all columns in the two tables that have the same name. That means whichever table names are common, automatically it join based on that particular column name. It selects rows from two tables that have equal values in all matched columns. If the columns having the same names have different data types, an error will be returned. Okay. So for example, they will take the previous example itself. Okay. So table 1. So we have two attributes A and B. Okay. We have two attributes A and B. So this is A1, B1, A2, B2. And we have another table T2. In this T2, we have two attributes A and C. Here also we have A1, C1, A2, C2. What happens is, here this A is common, right? So normally it will join based on this common attribute, and it will check for the data type. The data type also should be same. The size should be same. Then only you can join. If Name is same, but the data type is if it is not same, it will display error. Okay. So what's the syntax? Select department ID, comma department name, comma location ID, comma city. From department table, natural join locations. So here what we are doing, we are joining department table as well as location table using natural join. So you have to use the keyword natural join. When you consider these two tables, departments and location, which is the common attribute? Location ID is the common attribute. Okay, location ID is the common attribute. So based on that location ID, join operation will happen. Got it? So now we'll see how to use this using class. Creating joins with the using class. If several columns have the same name but the data types do not match, the natural join class can be modified with using class. To specify the columns that should be used for an equijoin. Use the using class to match only one column when more than one column matches. Do not use table name or allies in the referenced column. So normally we don't use the table name or allies in the referenced columns. The natural join and using classes are mutually exclusive. What do you mean by that? When you use natural join, you don't use using. If you are using class, you don't use natural join. Okay, any one you can use. For example, here we have two tables. In the first table in T1, you have A, B, and C. Okay, and in the second table, you have attributes A, B, and D. Got it? So here, which are all the common attributes? A is common. Here also A is there. B is common. Okay, here also we have B. This is not C. Okay, you please have this as D. Okay, so A and B are common. That means more than one column is common. Normally, how this natural join works, it will join based on the common attribute. Here we have more than one common attribute. So you have to specify based on which attribute you wanted to join. Based on, even though assume that even though this name B is same, they may have different data types. This B may have different data type. Assume that only this A is having same data type and you wanted to join using this A attribute. In that case, you have to use the class called using. Now we'll see an example how to retrieve records using class with the using class. So here we are going to retrieve employee ID, last name and location ID from employee table. Okay, here you have to mention join, simply join. You should not mention natural join or equijoin, nothing. You just use the keyword join. Okay, in the from class, what we are mentioning? Employee table joined with department table using, okay, department ID. Explicitly we are specifying, okay, using which attribute you wanted to do the join operation, that we are mentioning. In this example, this is not actually department ID. We have joined using location ID. Okay, this is not department ID because in that two tables. 1 minute. When you consider this location table, okay, so in this case, employee ID it's correct only because this employee table and department table contains department ID. Okay, so explicitly we are mentioning that we wanted to perform the join operation using this department ID. But don't get confused with the example because the example, okay, here actually we are retrieving location ID, okay, sorry, employee ID, last name and location ID, okay, from this employee table and department table, but it is joined using location ID. Okay, it is joined using location ID. Please note down these tables. this is your employee table. Okay, in the employee table, you have last name as well as department name. And then you have your department table. In the department table, you have department ID as well as location ID. So you have to say based on which attribute you wanted to join. Okay. Another way of performing join operation is using on clause. So I have told you about cross join. This is cross product. Also, we have discussed about natural join. So automatically it consider the common attribute. Yeah, otherwise, you have to use, if you have more than one attribute that has the common name, then you can explicitly specify using which attribute you wanted to perform the join operation, or you can use the on clause. Okay, or you can use the on clause. The join condition for natural join is basically an equijoin. What is equijoin? What is equijoin? In the previous case, we have discussed about equijoin. Equijoin is actually if you have equal to condition in your join condition, that we call it as equijoin. So natural join is basically equijoin because it is going to compare equality between the two attributes that are common. To specify arbitrary condition or specify columns to join, okay, you can use the class called on class. The join condition is separated from other search condition. In this case, the join condition is separated from other search condition. For example, you wanted to give additional search condition in addition with the join condition. So in that case, normally we use this on clause. The on clause makes code easy to understand. Okay, it uses code easy to understand. Now we'll see an example, then it will be easy for you to understand. Retrieving records with the on clause. See here, we are going to join two tables, that is the employee table and the department table we are joining. And from these two tables, we are retrieving employee ID, last name we are retrieving, department ID we are retrieving, as well as, okay, this department ID is from department table and this is from employee table, and also we are going to retrieve this location ID. Okay, so this is your fourth attribute and this is your fifth attribute. So these are the attributes we are going to retrieve, and here I am mentioning the join condition using on clause. So what we are saying, join employee table and department table on this department ID. On which attribute? On department ID. EDA department ID is equal to DDA department ID. So in this is assumed that this is a department ID from employee table. This is department ID from department table. So whichever rows are matching, only those rows will be retrieved. So here also, assume that you wanted to join more than two tables. That is, you wanted to join employee table, department table, and location table. So how to do that? Very simple, the same way, but you have to apply another join. So what you're doing, you're joining employee table, join department table. So this has been joined employee table and department table, and now you just give the join condition. So what's the join condition? Department ID. Okay, so D dot department ID is equal to E dot department ID. That is the common attribute. Now what you're going to do, you're going to join that with the location. You're going, okay, so apply again, you're going to apply join operation with the location table. Using which attribute? Using the location ID. Okay, using location ID, we are going to join. Got it? So this is the way in which you have to use the on clause. Now, very important topic we are going to discuss, that is inner join versus outer join. So in SQL 1999, the join of two tables returning only matched rows of an inner join. So, as I said, whether it is natural join or inner join, what it does, it returns only the matched rows. A join between two tables that return the result of the inner join as well as unmatched rows sometimes, okay, you may wanted to retrieve data from a left table even though it is not matched. So that is called left outer join. I'll give you an example, then you will understand it clearly. So a join between two tables that returns the result of an inner join as well as the result of the left and right join, okay, is a full outer join. Now you try to consolidate or summarize the different types of joints. Basically, two types of joints, inner join and outer join. So inner join means it returns, okay? So returns records that have matching values. See this example, you will understand. Okay, so whichever rows are matching, whichever rows are available in both the tables, table 1 and table 2, only those matched rows will be displayed in case of inner join. Okay, in case of outer join, even though it is not matched, it will retrieve. So for example, when you say left outer join, so what it does is it retrieves all the rows from the left side table and matched rows from the right side table. Okay, so all rows from the left side table plus matched rows from the right side table. That is left outer join. What is right outer join? All rows from the right side table plus matched rows from the left side table. What is full outer join? Whether it is matched or not, all the rows will be retrieved. Okay, all the rows will be retrieved. Now I am going to give you example. So please note down this example. Then you will understand better. For example, very simple example we'll take, then it is easy for us to understand. So I have two tables, A and B. I have a table with two attributes. Okay, A and B. I have A1, B1, A2, B2, and A3, B3. So this is my table 1. Again, I have another table. Okay, I have another table, that is T2, and this T2 has two attributes. Okay, A and C. A and C. So here in this, I have A1, C1. Okay, then A3, C3, A4, and C4. This is my table 2. Now we will see what is this inner join. Inner join is represented using this notation in relational algebra operator. I'll tell you what will be the result of this inner join. So from the table itself, you can understand which is the common attribute. A is the common attribute. So when you apply inner join, it will be joined based on the attribute A. And you know that in inner join, whichever rows are matching, only those rows will be retrieved. So what will be your result? So your resultant table contains A, B and C, right? So this attributes will be available for your inner join. So only matched rows will be taken. So here A1 is matching, right? Here A1 is matching. Here also you have A1 and A2 is not available in table 2, so that will not be retrieved, and then A3 is matching. Here also you have A3. So what will be your resultant table? The resultant table will be A1, B1, C1, A3, C3 and sorry B3 and C3. Got it? So this is your resultant table for inner join. Now we'll see what will be left outer join. What is left outer join? So in left outer join again you will be having A, B and C, right? You'll be having A, B and C. So when you take A, B and C, what condition I said? Returns all records from the left table, right? Return all records from the left table. So it has to return A1, B1. Whether it is matching or not, it has to return all values from left table. So A1, B1, A2, B2 and A3, B3. So all rows will be returned from the left side table. And in the right side table, only matched columns will be written. So what are the matched columns? A1 is matched, right? A1 is matched. So what will be there? So it will be C1. So this is actually B2. Okay. So C1 will be there. A2 is not matched. So we do not know what is this C1. So you mention that as null. And what is A3, B3? Already here we have a matching row. So here it is C3. So this is your left outer join. Okay. This is your left outer join. The notation is this. Okay. Next we are going to see about right outer join. So in right outer join, what will happen? All the rows in the right side table will be matched. All the rows in the right side table will be matched. So what will be the result? You will be having A, B and C. So when you take A, B and C, from the right side table, you will have all values. So what will be there? That is A1. This is your C1, right? Don't get confused. This is C1. This is C1. Okay. This is C1. A1, C1. So C1 will be there. And A3, C3 will be there. And A4, C4 will be there. And we have a matching value for A1. So you include that value, that is B1, right? For A1, what is the matching value? That is B1. For A3, what is matching? B3, B3. And A4. For A4, we does not know what is the value of B because that value is not available in table 1, right? So here you include null. Here you include null. Okay. So here you don't include A2, B2 because that is not matched. Okay. Left side column, only matched columns will take. Now we'll see what is a full outer join. What is the full outer join? This is the notation for full outer join. Okay. Now we'll see what will be the result. So the resultant table will be A, B, C will be there. You will consider all rows from both the tables, left side table as well as right side table. So what will be the result? A1, B1, C1. Okay. All rows you have to take from the left side table. So I have to take A1, B1, C1. Then A2, B2. Okay. But C2 is not there. So you just include that as null. Similarly, you just include A3, B3 and C3 is there. Okay. So this already A1 included, A3 is included. Here A4 is there. So you have to include A4 also. So include A4 and C4. But we do not know what is the value of B, right? Because that does not have any matching value in left side table. So here you include that as null. Are you able to understand? So this is the output of left outer join, right outer join and full outer join. Basically two types, inner join and outer join. What is inner join? Inner join, it will retrieve only the matched rows. Outer join, even though the rows are not matched, it will retrieve. Three types of outer join. What are they? Left outer join, right outer join and full outer join. What is left outer join? All the rows from the left side table will be retrieved. Then only the matched rows from the right side table will be retrieved. What is right outer join? All the rows from the right side table will be retrieved and the matching rows from the left side table will be retrieved. What is full outer join? Whether it is matching or not, from both the tables, all values will be retrieved. What's the syntax? So select, you mention what are the attribute names you wanted to retrieve. So we are joining here. Okay, so here we are joining employee table. If you wanted to perform left outer join, you use the keyword called left outer join. So we are joining employee table, left outer join department table. So this is the syntax. Please note it down. In the from class, you have to mention the table name 1. So this is your table name 1. Then you have to mention the corresponding keyword. If you wanted to perform left outer join, you mention that. And this is your table 2. Okay, this is your table 2. So this is left outer join. And also you have to mention on which attribute you wanted to join. And you all know that department ID is the common attribute. You join based on that. Next one is right outer join. So here the same thing, instead of left outer join, you use the keyword called right outer join. Okay, that means all the values from the right side table will be retrieved and the matched rows from the left side table will be retrieved. Then you have full outer join. All other syntax are same. Now, assume that I have given some join condition. In addition to that, if I wanted to mention some additional condition, in that case, I can use an AND operator and add the additional condition. That is possible. Okay. Thank you.